what we're going to do is we're gonna generalize everything, meaning we're gonna do it without numbers, okay, and see how far we can go. And as we generalize things without numbers, we get formulas in the process. So we're going to start with the general form of standard form. Which is y is equal to a x squared plus bx plus c. And let's try to find vertex form without plugging in numbers, but just from this. So we're going to follow the same steps that we did on day 4 and day 5, and we're going to try this in general. So what's the first step? How do you complete the square? What's the first thing we do? No? What's that? No. Factor what? Okay, well, no. You focus on the parts with the x, and what do we want to factor out of that? Not x, a. So whatever is in front of x squared, we have to make a 1, really, is what we do. Whatever number's here, that's what we factor out, and that's what you have been doing if you look back. So we need to factor an a out of those first two terms. So it's going to be a times x squared plus something plus c. What is that? How do you factor an a out of bx? What's that? Not sure? Well, so if ever you're b divided by a, so you're dividing is what you're doing. When you're factoring, you're dividing. And so b divided by a x, right? If you think about if we had y equals 3x squared plus 9x, and you factor a 3 out, what you're really doing is you're dividing both of these by 3, and you end up with x squared plus 3x, right? So factoring out kind of goes along with the division, and so that's why we're dividing b by a. Okay, so that's our first step. Then we need to complete the square. And so here's where we use a little scratch work. And we're thinking, well, I have an x squared plus b over a x, and I want to add something to that to make this a perfect square. And I want my perfect square to be x plus something squared, right? And so the first thing we do is we take the b over a, and we use that to help us find what goes here. What do we normally do if there's a number there? You cut it in half, right? And now we got to do that with b over a. So we got to cut b over a in half. What's half of b over a? B over 2a. So when to find a half of something, you can divide it by 2, or you can multiply it by a half. Right? If I want a half of 10, that's 1/2 times 10, which is 5. So half of b over a, I multiply that by 1/2. So 1/2 of b over a is going to be b over 2a. And so that's what goes here, b over 2a. And then so we first figure out, okay, that's what I want it to become. That's our perfect square that we want to create. And then so we're going to use that b over 2a to figure out what we need to add. Do you remember how to do that? You square it. So what's b over 2a squared? B squared over, what's 2 times 2? 4, and a times a is a squared. So that is the number that we're going to want to add. So we have y is equal to a times x squared plus b over ax. See, and I'm going to add b squared over 4a squared. But if I add that on the inside here, what do I put on the outside? Negative what? Right? Because it's a times this here, right? So we're going to go a times b squared over 4a squared. I know it looks messy and complicated, but are you following the steps? Okay. So then we factor, create our perfect square, so that part in parentheses becomes x plus b over 2a squared, like we saw in our scratch work, plus c, and I'm going to reduce this fraction, so they got an a here, and I got an a squared on the bottom, so just ends up being an a on the bottom, so I end up with minus b squared over 4a. And this is a c over 1, and I'm going to want to I want to add this together to make one fraction. So I need a common denominator, so I'm going to multiply top and bottom by 4a. So I'll multiply the top of this fraction by 4a and the bottom of this fraction by 4a. Get y is equal to a times x plus b over 2a squared plus 4ac minus b squared all over 4a, because I had a common denominator, and so I can subtract and make it one fraction. And that is our vertex form. Pretty, huh? It's a beauty. Okay. So when you have vertex form, what can you find? The vertex. So can anybody give me the vertex? B over 2a, comma. Okay, so it should be a negative, right? Because it's the opposite, right? So negative b over 2a, because that's going to be the opposite of what's here. And that's our y value. Okay. And so that's a formula for a vertex. If I give you a, b, and c, you can plug it into that and say, here's a vertex, without solving anything now. You can. Okay. What can you tell me about the axis of symmetry? It's an equation, x equals negative b over 2a, and that's always true for everything. Okay. So we have a formula for our vertex. We have a formula for our axis of symmetry. Now, just to show you how this works, let's just take the easy. This is not too complicated of a formula for axis of symmetry, right? The other ones are, getting a little complicated. But let's grab this simple one: negative b over 2a. And I'm gonna come back to this if you didn't write it down. But I'm gonna take a look at our homework that we just looked at and see if we can apply it. So I don't know. Let's look at 27. Right? On 27, what's A? 1. What's B? Okay, and so what is negative B over 2A? Negative 4 over 2, which is negative 2. Is that our axis of symmetry? There it is. Right? So, and if you go back and look at all of them, you'll see that if you looked here and said negative B over 2A, would always be your axis of symmetry. Always. Always. And then what was the y value of the vertex? That formula? I don't know it. You guys wrote it down. That's a little more complicated. 4ac. So if you did that and tried that out, you'd get 9. I don't know if that's an easy one. That one may not be. But the negative b over 2a's could be helpful, right? And so let me get back to our notes. Okay. So for sure, I want you guys to definitely memorize this piece, what I'm highlighting. Okay. For sure, you have to memorize that. Optional if you want to memorize this part. Totally optional. I don't. What I memorize the negative b over 2a. And so if I need it, that gives me my axis of symmetry, and it also gives me my x value for the vertex. And I know if I have my x value for the vertex, I can just plug it into the equation to get the y value. So I don't really need to memorize that. Now some of you is like, well, I don't want to plug it in and find it. I just want to memorize that. And if you want to do that, you can do that. There's nothing wrong with that. Okay. But there we have. Now, if we have vertex form, we could solve for our zeros and our roots. We've been doing that. So let's keep going. Okay. So for our zeros, our roots, and maybe our x-intercepts. Why am I saying maybe? Because it might be imaginary. But if it's not imaginary, it will work, right? Let's come up with this formula that you can just plug in ABC and it will give you it right away. Okay. So I'm going to take my vertex form, a times x plus b over 2a squared plus the 4ac minus b squared over 4a, and set that equal to what? 0, and solve for x. All right. So what's our first step to solve for x? You think about what you've done this process. It just didn't look like this. Subtract this big piece here, right? Subtract that fraction at the end. So we get a times x plus b over 2a squared is equal to negative whatever that fraction is, 4ac minus b squared 4a. So I just subtracted it, just moved it over. Now a good idea, eventually I'm probably gonna take that negative and distribute it to the top. Because that negative is really negative 1 over 1, right? What's the next step? We have to divide by a, but I have a fraction and I don't want to divide a fraction by something else. That creates a complicated fraction. So instead of dividing, I want to multiply by something. What can I multiply a by that would be equivalent to dividing a by itself? Multiply by 1 over a. So multiply by 1 over a on both sides. What is 1 over a times a? 1, right? And that's why, so this piece becomes 1, and I just have an x plus b over 2a squared is equal to, I'm going to distribute that negative like I told you, so negative 4ac and a positive b squared. And then I'm going to multiply these fractions together. So what happens when I multiply the denominators together? 4a squared. Good. All right. We're well on our way to solving for x. We're almost there. What's the next step? Take the square root of both sides. So the left side, I'm going to have an x plus b over 2a, because when I take the square root, that cancels out the square. On the right side, don't forget plus or minus, yeah. Square root of the top over the square root of the bottom. This is what? We're getting there. You guys have heard of the quadratic formula? Some of us have, huh? So then I'm going to subtract b over the fraction here, and I get x is equal to negative b over 2a plus or minus. Can we take the square root of the top? Some of it? What? Okay, let me pull something over here. What is the square root of 3 plus 16? Can I take the square root of 16? Or do I have to add first? There's an implied parentheses here that says, hey, you have to add that first and get the square root of 19 and get stuck. Okay? And I show you that because we have a perfect square, b squared, but it's added to something else. Just like the 3 plus 16. And so we can't simplify that. How about the bottom part, though? That we can simplify. So the top part is stuck at negative 4ac plus b squared. The bottom part can simplify to 2a. Which is nice because I have two fractions and they have a common denominator. So I can make it one fraction. And we can finish it off. Top part of the fraction, negative b plus or minus the square root. I'm going to flip this around because I don't want to start with a negative. I'm going to put the b squared first and then the minus 4ac second. And then that whole thing is over the 2a. And that is a formula that we can plug in ABC, and it'll always give you your roots and your zeros, and sometimes x-intercepts if they're real. And this is the second most famous formula out there. The first one is Pythagorean theorem. A squared plus b squared equals c squared. Probably a lot of your parents can say that still today. This is the second most used formula. Now, your parents probably don't know this one, but this is called the quadratic formula. And I'm telling you, you have to memorize that one. You have to. Okay? Now, if you YouTube quadratic formula songs, you get a lot of stuff. That's how, this thing is pretty famous, I'm telling you. And so you could like people to try to remember this have put it to all kinds of tunes. For example, around Christmas time, someone may sing x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Hey, right? Or you guys have heard like the toy Jack in the Box, dun, 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 right? You could do that with this. You could go x equals negative b plus or minus square root of b squared minus 4ac all over 2a, right? So you have to memorize it. I don't care how you memorize it. You got to memorize that. By tomorrow. By tomorrow. Yes, and that's not an April Fool's, right? Okay. It's not too bad. We're going to practice using it, and as we're using it, we'll remember it. So, by the way, okay, you guys are moaning and groaning over memorizing that. Let me tell you something. The state standard is that you can derive that, which says start here and do all of this to this spot all by yourself without Mr. Marsh. And that's a standard not for honors, that's for regular math too. Okay? So no, I want you to be able to get there. I do want you to memorize it because you're not going to do that every time you do it. But yes, you also need to know how to work through that process, and we'll practice that some more. But so this is not a just like let's forget about it. Hopefully you copied that down. Okay. All right. So now let's use it. Let's use it. So let's go to 31. I'm not sure what happened on the right side. I should have had more information over here. It kind of got deleted, but we know it goes there, and we'll fill in the blanks. Okay. But here, for these 6 problems, I want you to do them in this specific way because you guys have now quite a few methods in your toolbox to use, and the method of completing the square, you could use that, and you don't need what we just did, the quadratic formula and all that stuff. Completing the square, somebody just got tired of doing completing the square over and over and over again, and they just developed that formula. So let's just plug it in the formula. Okay. So you could always use completing the square, or you could use that formula. They both work. Although completing the square in this gets really ugly because, well, you could try it on your own if you really want to. But we're going to use, this is the process I want you to do on these 6 problems. So first, find the y-intercept, which is plug in 0 for x, and you get y as 2, so 0, 2. Then, okay, the first thing I want you to memorize is x equals negative b over 2a. Okay? And that goes with your axis of symmetry. Right? And so plug it in. Find out what that is. So in this problem, a is 2. That's the number in front of x squared. B is negative 3. That's the number in front of x. And c is our constant, which is 2. And so if I plug that into the x equals negative b over 2a, I'm going to get x equals negative, and then b is negative, so I got a double negative, so negative negative 3 over 2 times 2. And what does that come out to be? Positive 3/4. Right? Positive 3/4. And then after you find your axis of symmetry, find your vertex. So we know the middle is 3/4, so the vertex is on the middle, and so it has the same x value. And we need to find the y value. Your choice on the y value. The way I'm going to do it is I'm going to plug in x into my equation. The other way you could do it is you can memorize that formula. It'd be a third thing you got to memorize. I'm not going to memorize it, but you could, and I'm okay with that if you're good at memorizing things. And so I'm going to just take this 3/4 and I'm going to plug it into my standard form. And I get 2 times 3/4 squared minus 3 times 3/4 plus 2. And this is going to be a little bit of work because we got fractions. We can do it. That would be the benefit of doing the formula. You don't have to deal with fractions. So here we got 2 times 9 over 16 minus 9 over 4 plus 2 over 1. And I need to get a common denominator between the 3 fractions. I get 18 over 16. Second fraction, I'm going to multiply top and bottom by 4 and get 36 over 16. And last fraction, I'll multiply top and bottom by 16 to get 32 over 16. And then after you have a common denominator, you can add and subtract your numerators. I'm going to add the last 2 first. And I get 18 over 16 minus 4 over 16. And that's 14 over 16, which is 7 over 8. So 7 over 8. Now I found my vertex. After you find your vertex form. Okay. So again, tracking our order, we went from here to axis of symmetry, axis of symmetry to vertex, vertex to vertex form is what we're doing. Okay. So what is our vertex form? We got all the pieces. We just got to put them together. Y equals 2x minus 3/4 squared plus 7/8. All right. After you do that, then you're going to use the quadratic formula to find your roots. Use the quadratic formula. And this is where you're practicing memorizing it as well. So you're going to write it out. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay? And every time you do it, just keep trying to memorize it and look back until you feel comfortable with it. And then you're going to plug in a, b, and c. When I plug them in, I tend to put them all in parentheses. So whatever I plug in, I put in parentheses. It will be helpful in certain situations. So negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times 2 all over 2 times 2. So that's what it looks like when you plug things in. I use parentheses for my a, b, and c. So some people have a great time memorizing and plugging in like that, but then make mistakes after this part. So you also need to know, well, how do I simplify that? What do I do first and second? It's not too bad if you know the correct steps. Focus on what's underneath the square root and save that subtracting for the end. Okay, so there's really, you got to see underneath that square root, there's really two terms or two pieces. There's the negative 3 squared, which you can find, and then there's the 4 times 2 times 2, or the 4ac. You got to find that one, okay? And then after you find those two, then you subtract on a step later on, okay? And then there's some minor stuff you could do on the outside of the square root, the double negative or the 2 times 2 in the bottom. And so I'm going to do all that in this next step. So x is equal to 3 plus or minus the square root of 9 minus 16 over 4. That's what your next step should look like. Then you subtract the 9 and the 16, and you get negative 7. So 3 plus or minus square root of negative 7 over 4. So now you see we have a square root of a negative. It's imaginary, right? And so we need this. How do we simplify that? We write x equals 3 plus or minus what? I root 7 over 4. And that's as much as we can do before we split things up. And so those are our roots. And so for our roots, we're going to write 3 plus I root 7 over 4, comma 0. And the second one's going to be 3 minus I root 7 over 4, comma 0. So after vertex form, you use that quadratic formula. Now some of these 6 problems will be factorable and some won't. Some will work out and you get factors. Do we have factored form on this one? If your roots have square roots in them, not going to work out. Or if they're imaginary, not going to work out. But if you just had a fraction, if I just had like 3/4, it would work out. Now, again, for memorizing, I want to show you something in the quadratic formula. Notice this. You see it? So in your quadratic formula, if you take that square root away, you get the negative b over 2a, which is the middle, or the axis of symmetry, right? And so It's kind of built into that. So you got your negative b over 2a, and then that part is what we, that's got a name too, but we're not going to go into that right now. So we have no factored form. All right. Now we're ready to finish this off. We're going to graph. So let's call this 1. I'm going to really space it out here. 2. 3/4 is the center. And 3/4, 7/8. So that's 7/8 is a little bit less than 1. So about right there. That's my 3/4, comma 7/8. My vertex. We know we have a y-intercept at 0, 2. If we reflect that across the axis of symmetry, where is that going to be? So we're 3/4. So we need to add another 3/4 to 3/4, and we end up at 1.5 or 1.5. We get 6/4, which is 1.5. So that right here at 3 over 2, comma 7/8. No, it's comma 2. So we got 3 points. We need a couple more. Let's plug in 1 into the formula. That would be easy. So if I plug in x equals 1 into standard form, what do I get for y? It's not going to be a fraction. It'll be a nice number. You get 1. So 1, 1 is another point. And if we reflect that across the axis of symmetry, where do we get? So 1/2, 1. And now we got 5 points. And you do not have to, if this is tough for you to reflect stuff with fractions, you don't have to do that. You could just keep plugging integers into the equation and getting points. But if the reflecting is sometimes less work. Okay. All right. I'm going to put my 5 points in a table. And our domain, still all real numbers. Our range, all y values greater than or equal to 7/8. It's increasing for x greater than 3/4 and decreasing for x less than 3/4. And now we completed our problem. Questions on that one? So formulas are shortcuts, and that's what we've created. We created a couple formulas, which are shortcuts, but we created those formulas from a lot of background, a lot of understanding before that, right? Let's your pick, 33 or 34. 34. Okay. 34 it is. Anybody else want to speak up? 33. Okay, 33. That's fine. We're going to follow the same order of things. So what do we do first? Y-intercept, which is 0, -2. And then axis of symmetry. So we know A is 6, B is 1, because there's a 1 in front of the x. Don't put 0. It's a 1. And C is -2. When would one of these be 0? If it's missing, like if there is no x there at all, if you just had 6x squared minus 2, that would mean B would be 0. Okay. And so then remember, practice memorizing the axis of symmetry formula, which is x equals -b over 2a. No, yeah, -b over 2a. I said it right. And so that's going to be -1 over 2 times 6, which is x equals -1/12. And then from the axis of symmetry, you find your vertex. The -1/12 is my x value, and I want to find the y value. So you can plug -1/12 into that formula, or you can memorize the formula for the y value. I'm going to plug it in. So my y value is going to be 6 times -1 over 12 squared plus -1 over 12 minus 2. Go ahead and try to simplify that. I will do that too and see if we come up with the same thing. What are you guys coming up with? -49 over 24. What we want. And then from there, you're going to create your vertex form. All right. And there it is. And then we're going to find our roots using the quadratic formula. And work on memorizing it again. X equals -b plus or minus and then plug in a, b, and c into that. And it looks like this, and I'm going to pause here and see if you can finish that. right, so on this one, you guys can back up, but take a look at this. So you're going to end up splitting it up. You get -1 plus 7 over 12 and -1 minus 7 over 12.
Liliana Villanueva, Hudson Burt, and Timothy Morris, please report to the attendance office. Alexis Aguilera, please report to attendance. Alexis Aguilera, you need to report to the attendance office.
So here we have fractional roots. Does it? Yes, it factors. So you got to find factored form and go from there.